0 marks. Literally 0. That is exactly what this perfectly calculated standard form answer scored on the recent Cambridge IGCSE Physics 0625 exam. No fluff today, we are jumping straight into a high-stakes Brownian motion speedrun.
Picture this. You're sitting in the exam hall, right? The clock is ticking down, and you have just nailed the complex math of standard form. Your calculation is totally flawless. But when results day finally rolls around, you find out you lost a crucial grade boundary over a tiny, easily preventable error. Why on earth did this perfectly calculated standard form answer score an absolute 0?
Let's do a quick topper autopsy here. The fatal mistake was, honestly, microscopic. The flawed answer simply read 3.5 times 10 to the power of -8. But the perfect answer? 3.5 times 10 to the power of -8, followed by the letter m. Yep, the student simply forgot to include the final unit of measurement for meters. It's such a painful trap, and today, we're going to make sure your physics answers are completely bulletproof.
Section 1. Visualizing Brownian motion and gas pressure.
Okay, let's dive right into this. Because before we can master the math that trips so many students up, we really need to understand what it is we're actually measuring. How do we physically observe something as chaotic as Brownian motion and gas pressure? Well, this brilliantly illustrates the exact experimental arrangement you need to memorize. Let's take a quick guided tour of this apparatus, shall we? Up at the top, we've got the microscope, looking down through a cover slip directly into a smoke cell. Crucially, notice the light shining in from the side. The smoke particles inside this cell are just large enough to be visible under the microscope when they're illuminated by that side light. They show up as these tiny, bright specks dancing erratically. Why? Because they are being constantly bombarded by invisible, super fast-moving air molecules. But to actually do the physics, we need measurements, which brings us to a foundational concept, diameter. Basically, a straight line connecting 2 points on a circle or sphere that passes straight through the center. This is the exact metric we are about to speedrun calculating for one of those tiny dancing smoke particles we just looked at.
Section 2. The topper answer framework and math breakdown.
Let's see how this builds into our overall strategy. We're going to break down the standard form math calculation exactly how Cambridge examiners want to see it, step by meticulous step. Now, listen closely. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you absolutely need the framework that makes that clue obvious. If you skip this framework, you're going to be vulnerable to the exact same grade-dropping mistakes as the student we just talked about.
All right, here is the core math challenge pulled straight from the source. The diameter of a smoke particle is 0.00000035 meters. How in the world do we express this in standard form? Well, the key question you need to ask yourself immediately under exam pressure is this: does this process involve dividing or multiplying by 10 to get the power? Since we're working with an incredibly small number, division by 10 is definitely involved.
Let's break it down together. Step 1, look at the groups of digits. Reading from left to right, you want to find the very first digit that is non-zero. That's our 3. The decimal point goes right after this digit, giving us 3.5. Step 2, work out the decimal number you need to multiply 3.5 by to equal the original microscopic number. That gives us 3.5 multiplied by 0.000000001.
Now for step 3, we need to find the power of 10. How many times does 1 have to be divided by 10 to become that tiny decimal? Imagine just moving the 1 to the right, place by place. 1, 2, 3, all the way to 8 times. So it's 10 to the power of -8. Finally, step 4. Substitute that power of 10 value back into your equation. Your final, beautifully calculated answer is 3.5 times 10 to the power of -8 meters.
Now, what's really interesting about this is the direct, urgent warning straight from the examiner's source material. Quote, "Look out, don't forget the unit in your final answer." I really want to hammer this home, guys. This is literally the biggest Cambridge trap. You successfully navigate the standard form math under intense time pressure, you write down 10 to the -8, and then you just lose the mark because you left off the M. Do not let this happen to you.
Section 3. Spot the Error Interactive Challenge.
You know, math isn't the only place where marks just slip away. Written explanations are honestly just as dangerous. So let's test your knowledge in our rapid-fire check to see if you can instantly spot what separates an average answer from a topper answer. Take a look. A flawed student answer often says something super vague like, the smoke particles move fast because of the gas. It relies on vague wording and early rounding. It scores terribly. Now look at the bulletproof topper answer framework right next to it. An improved answer clearly states the concept, provides evidence, applies scientific reasoning, and uses exact examiner wording. It reads, smoke particles exhibit random, zigzag motion due to collisions with lighter, fast-moving, invisible air molecules. You see the difference there? It's night and day.
Let's rapidly rattle off the ways students hemorrhage marks in thermal physics just to raise the stakes here. You lose marks for missing units, rounding way too early in your calculations, giving vague explanations instead of specific kinetic models, making catastrophic graph axis scaling errors, suggesting weak practical improvements for your apparatus, testing the wrong variables entirely, or drawing conclusions that simply aren't supported by the data table.
So, the absolutely crucial point here is applying this specific 4-part framework to construct a top-band answer every single time. 1. State the core concept. 2. Reference your evidence or data straight from the question. 3. Connect them with crystal-clear scientific reasoning. And 4. Polish the whole shebang with precise examiner wording. If you filter every practice question through this, your marks will absolutely skyrocket.
Section 4. Your next speedrun challenge.
Okay, you have done fantastic work today. We've conquered standard form math and established a really rigorous framework for answering kinetic particle questions. But let's raise the stakes one last time. You've mastered the standard form math, sure, but what happens when the examiner throws a catastrophic graph axis error at you in the middle of a high-pressure thermal physics paper?
If you don't know how to analyze that data and scale your axes flawlessly, you are going to lose massive marks, and all the standard form math in the world won't save you. Ask yourself, the next time you sit down with a complex set of thermal physics data in the exam hall, will you control the graph or will the graph control you? It's time to bulletproof your graph skills. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and click the video on screen right now to master the exact timed answer writing system you need to survive. I'll see you over there.